This question is about thermodynamics. Consider the reaction shown. Table 7 shows some thermodynamic data. We can see we've got enthalpies of formation and entropy values. Explain why the standard entropy value for carbon dioxide is greater than that for carbon. So remember that entropy value is a measure of disorder. Carbon dioxide is a gas. So much more disordered than solid, which we know is arranged in those nice layers, carbon. State the temperature at which the standard entropy of aluminium is 0 joules per Kelvin. Well, the only time that you would have zero disorder is if you have zero temperature. And that would be in Kelvin, not degrees C. Use the equation and data in table 7 to calculate the minimum temperature in Kelvin at which this reaction becomes feasible. So it's feasible when delta G hits 0. So when delta H equals T delta S. So when T equals delta, so T would be delta H over delta S. But what we'll need to do is find out delta H and delta S first. So delta H, we're going to do the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. So we're going to go back and have a look. See, we go all the way up here. So we want the products, 4 aluminiums and 3 carbon dioxides. So we want 4 lots of 0 and 3 lots of minus 394. And then we're going to subtract from that 2 aluminium oxides. Oops. There's 1,669 and 3 lots of 0. So we've put that into our calculator and we get 2156 kilojoules per mole. Then we're going to do delta S in a similar way. It's the sum of the entropies of the products minus the sum of the entropies of the reactants. So we're going to do a similar calculation. So 4 lots of 28 and 3 lots of 214 minus 2 lots of 51 and 3 lots of 6. So again, you're going to put that in your calculator. And if you work that out, you get 634. But remember that this one is in joules per Kelvin per mole, not kilojoules per mole. So when we go to use that in the equation that T equals delta H over delta S, we need to have comparable units. So 2156, but if we want the 634 to be in kilojoules per Kelvin, we're going to need to times 10 to the minus 3. If we put that in our calculator, we get 3,400 or 3,401 Kelvin.